By the end of this tutorial, this Python agent will do three things by itself: ask you for the information it's missing, call a train search function, and stop as soon as it has enough to recommend the cheapest option. No framework, no magic. About 60 lines of ordinary Python. In part 2, we designed this behavior on paper. One exact goal: find the cheapest train from Paris, the inputs it needs, the tool it may use, the state it keeps, and the rules that make it stop. A blueprint becomes useful when we can turn each box into working code. That is all today is. The state box becomes a data class. The toolbox becomes a function. The stop rules become guards, and the whole thing runs in a loop. Before any loop logic, define what the agent remembers. It is a small object holding the goal, the inputs collected so far, the results a tool returned, and a step counter. In Python, that is a data class with origin, destination, date, options found, and steps taken. Build this first, because every other piece of code reads from and writes to this one object. If the shape of the state is muddy, the loop wrapped around it will be muddy too. This is the blueprint's state box, turned into code almost line for line. Tools are not magic. They're functions with a clear input and a predictable output. Our train search takes an origin, a destination, and a date, and returns a list of options, each with a price and a duration. Write it as an ordinary function first, returning hard-coded data so you can test the loop without touching a real service. Keep the signature boring. The reason we separate the tool from the loop is that you can swap fake data for a real API later without changing a single line of your decision logic. Decide is one function that reads the current state and returns an action. Ask the user, call the tool, or finish. Check the fields in order. If the date is missing, return ask user, along with the question to put to them. If the date is there but no options have been found, return call tool. If options exist, return finish, because the agent now has enough to recommend something. This is a plain if chain, not reasoning. That is deliberate. Nothing here is deciding anything intelligent, and I want you to see exactly where the decisions come from before we hand any of them to a model. Now the loop. At the top, check the step limit. That guard is what makes everything below it safe. Then call decide, count the step, and act on what comes back. If it says ask user, print the question, read the answer with input, and write it into state. If it says call tool, run search trains and store what comes back. That assignment is the observe step, the moment the world gets written into the agent's memory. If it says finish, print the recommendation and break. Then round we go again. Notice the counter goes up once per cycle, whatever the agent chose to do. Asking costs a step, calling a tool costs a step, finishing costs a step. That is what makes a step limit mean something. Go back to the blueprint's stop rules and confirm each one is reachable in the code you just wrote. Success. The finish branch prints a recommendation and breaks cleanly. Step limit. The guard at the top catches a runaway and says so instead of dying silently. Clarification. The ask user branch covers it, and because asking costs a step, an agent that keeps asking still runs out. Permission? Not needed yet, because this agent only searches. Leave a comment marking exactly where an approval check goes once it can book something. Walking the blueprint against the code is how you find the gap between what you designed and what you actually built. Run it once more and watch the sequence rather than the output. Ask, then call, then finish. 3 steps, printed in order with the state visible between them. Watch the date field fill in after step 1 and the options list fill in after step 2. That trace is the thing you debug. When an agent later does something strange, you will not ask, what did it say? You will ask, which branch did it take? And what was in state at the time? Print those two things from the very first version, and you will save yourself hours. You now have an honest little agent. It tracks state, decides with rules you can read, calls a function, observes the result, and stops when told. Two things are still missing. The search returns the same 3 made-up trains no matter what you ask it. So the loop runs, but it still cannot look anything up. And every decision in it is an if chain you wrote by hand. Next episode, we fix both. How to describe a tool so a model picks it correctly, how to validate what comes back, and how to add guardrails before an agent touches anything real.